Greetings. For today, we have a PCB that I rescued a while ago out of the junk pile. This is a soundboard for an early Bally solid-state pinball machine. Late 70s, was used in several games. Two I can think of. One was Space Invaders and also the Rolling Stones. Condition is unknown, but basically it was the second generation of soundboards that Bally used. The first generation was just a bunch of analog circuitry trying to simulate the chimes that they had in those machines. And bleeps and blops. Probably no blops, just bleeps. It sounded pretty bad. And finally they upgraded to this. This is actually using a digital sound chip. The General Instruments AY-3-8910, which has 3 channels of square waves and some amplitude control. And then, of course, the complement of other chips. We have the processor. Which one is that? The processor is U3 over here, which is a 6808, which is like a 6802 that failed the memory test because it has onboard memory. And I think we talked about it before, so they decided to change the number to 6808 I mean. And you need an external memory chip for that. And it has a PIA, parallel interface adapter, and other assorted goodness here. Here we get into the analog section of the whole thing. And here's basically a power amp, few watt power amp, a TDA 2002 that drives a speaker directly. It interfaces to the CPU board through this connector, which supplies power and control signals to activate sounds, and speaker connector. And that's basically it. I have no idea as to the working condition of this. So let's have a quick look at the schematics and come up with a plan on how to test this. So just for reference, here are the schematics. Here's the big connector that supplies power and also control signals down here coming from the CPU board. We have a U3, which is a 6808 processor. This is an EEPROM because it was used for several machines. 6821 PIAs over here, 6810 RAM, because the 6808 doesn't fail the RAM test at the factory. So if this chip successfully passed the RAM test at the factory, the onboard RAM, it was called a 6802. This one failed, so they called it a 6808, and you put an extra RAM. U1 is the AY sound chip, and then the rest of it is preamplification and amplification of the audio driving speakers. Curious thing they did was the sound chip actually has 8 I/O ports on it, and you can notice that there are several I/O ports not used on the 6821. Instead, they use the I/O ports on the sound chip. And the way that works is the CPU reads the sound chip, and that returns the state of these. These pins are configured as inputs, and it reads these pins. Why they didn't use this? I guess it was a coin toss because the port bits were available in both places, and maybe the layout was easier to do this way than this way. As far as the amplification is concerned, a lot of nickel and dime stuff in here, an LM3900 used as a preamplifier, a mechanical volume control over here, and the TDA 2002, which is the power amp feeding the speakers. So there you have it. So how are we going to test this thing? I mean, the academic way would be, of course, to start at the processor. Do we have a clock input? Do we have signals jumping all over the place? Are we getting a proper reset signal? And kind of make our way through it, and it could take a while to do it that way. So today what we're going to try is a divide and conquer approach. If we look at this section, this is basically the cutoff between digital and analog. And the first divide we're going to look into, see if anything comes out of the digital portion, the square waves, and then see how they travel through the preamplification and final amplification in here. You may have noticed that I'm assuming it doesn't work all of a sudden, but that's because I found a small sticker underneath the board that says no worky. So that was all it said. No indication as to what's happening, why it isn't working. So when we test the PCB that doesn't come in a case and a wall wart, i.e. power supply, we have to simulate the power portion of the whole circuit, unless we want to stick it in a pinball machine, but we want to bench test this thing. So I have all the power supplies, as you may remember, right there in the middle, but this is easier. This is an old moldy PC supply, but it does give us a lot of voltages and a lot of current, which is nice, which you don't really need, but we got plus 5 volts, plus 12, minus 5, and plus 3.3 coming out of this thing. So that's our power supply. Then we need a harness to properly power it up. The board needs 5 volts and 12 volts. So we're going to plug this in. And another thing on the board is we're not using any of the interface signals on this connector, which are over here, but it's got a test switch here. And if this thing works, you press the test switch and it makes some sort of noise. The last thing we need is an honest-to-goodness speaker. Since the signal coming out is already amplified, that's pretty much all we need to test this. After looking at the PCB, there seem to be a few things missing. This is U4, which is supposed to have a 2716 EEPROM. There's a cap, a 4700 microfarad cap over here. But the only purpose of this is to bypass the supply voltage, the 12 volts, which is only used on the power amp. Obviously somebody needed this. It shouldn't affect operation other than because it isn't, running this without this capacitor may cause some hum. But that's the least of our worries now. One other thing I noticed was this spot marked U7 and some associated passives over here were left out at the factory. It was a 555 timer that I guess was used as a reference timer, but in the end they decided they didn't need it after all, so this is not used. So conveniently, test point 6 over here is the output of the sound chip. So what we can do is, well, the first thing we should do is to hook it up and verify the quote customer complaint. If it's properly hooked up to power and a speaker, does it emit any sound? Well, I got it hooked up. And I burned an EEPROM for it. I found the image for the Rolling Stones machine. Obviously, it wouldn't work without an EEPROM. As explained, we don't really need this cap. Absence of it is only may cause the output to hum. But that's basically it. So let's switch on the power supply. Make sure the volume is cranked. Well, we don't want to crank it because it gets kind of loud. And nothing. It's supposed to make some sort of noise, but as the sticker underneath let us know, it doesn't work. So since it's an audio board, a sound board, and we found our divide spot on where to start, basically the interface between digital and analog, let's get a small amp and just follow the sound. We can't just use a speaker because the output is very low level over here and will not be able to necessarily drive the speaker if we actually check the signals going through here. And when we don't hear anything, we may assume that we found the problem, but that's usually only because the level is too low. So let's get a hi-fi amp so we can trace the sound, if there is any, of course. Okay, we got the reference amp hooked up, and I'm connected to all three outputs of the GI sound chip. They're all wired together, and they have a convenient test point over here, test point 6. So, is the digital part of this circuit working? Yes, it is. So now we can actually trace through the analog circuitry. So, just for grins, pin 3 on an LM324 is the input to the preamp. It is attenuated, but there is sound here. Oh, that isn't working too well. Let's use a better probe. We can hear that. That's the input. Sorry, that's loud, but that's the output of the preamp. And then the input to the power amp is pin 1. It's obviously getting a signal. And finally, we need to have a look at the output, which is pin 4, which is buried somewhere under there, but it directly feeds C8. Which is this. And it feeds the positive side of C8. So that's the output of the power amp over here. Nothing. Nothing. So basically we have it isolated now to the part where the signal's making it all the way to the power amp. But it's not coming out the other end. So what do we do next? Of course, the next step is that we suspect the power amp itself, but having looked at it and the thermal paste and stuff like that, this has been replaced. I mean, the solder joints look shiny, so this guy was replaced. So the only other thing is if we assume that this is working, was to check whether it's getting supply voltage, whether the 12 volts is coming to it. And the 12 volts goes into pin 5, and it basically, the 12 volts comes in through this connector over here, goes through a trace, hits a diode, and basically over here we have 12 volts. And we can see that the trace runs to one end of the bypass capacitor, and then underneath it runs to pin 5 of the amp. So at this point we do a continuity check. Well, even better than that, we do a voltage check. So we go to ground. We're getting our 12 volts. We're hitting one end of the diode. It's coming out the other end of the diode. It's going to the positive marked part of the capacitor, and it's going nowhere. It's supposed to go to pin 5 on the power amp. And looking at the other side of the board, here's the positive end of the capacitor. It goes through here, and it's connected to pin 5. So now we do a continuity check on that. And we got continuity. So the only possible way that could happen is if this via is bad. Oh. See that bouncing? The trace has separated. And there is no via. The via is a component lead. So what happened here, the board, the capacitor, the bypass capacitor for the 12 volts was removed, and by removing it, the via was removed. So the power amp isn't getting any power. And we can test that real quickly by creating a temporary connection between the 12 volt feed over here and pin 5 of the power amp. Alright, so I basically test point 1, which is the 12 volts over here after the diode, and I hooked that up to pin 5 of the power amp. Hooked up the speaker again. So, did we fix it? Well, we found what was wrong with it. We haven't fixed it yet, but Let's see if the volume works. That gets pretty loud, actually. Well, there you have it. The problem was the cap was removed, and that didn't work because the positive lead of the cap also acted as the via. So let's see what kind of a cap I can find and put this thing to bed. Alright, I replaced the cap, even though I was correct in my analysis that the cap wasn't needed electrically to function, but obviously it was needed mechanically to function. So we're all hooked up, we got the speaker here, and does it work? Yes it does, and it's ready to go and give the gift of music to a lucky pinball player. Thanks for watching. Please like, subscribe. Oh, by the way, when you subscribe, you're supposed to hit the bell icon because otherwise it won't inform you. Leave me a comment and all the other good stuff. And somebody asked me, they said, what if we want to donate money to you? We don't want to donate equipment. Well, go to the same link, afdonations@aol.com. And that's where I can give you instructions. Bye.